Hello everybody, and welcome back to Catalysis, Discovery and Technology Tool, where we discuss and explore catalysis and its future in science and medicine. Today, in our last lesson for the unit, we will be discussing biomass for renewable fuel source. So, let's get right into it. This lesson will answer the questions: what is biomass and why is it useful? Why should it be useful as a fuel source? And how can biomass be converted into useful fuels? Biochemical processes and thermal processes. So what is biomass and why is it useful? Biomass is any recently living material used for energy production. Biomass is considered a renewable resource. Although fossil fuels come from once living sources, they are not considered biomass. This is because naturally occurring geological processes are needed to convert the ancient material into fossil fuels. Importantly, these processes are so slow that fossil fuels are not considered renewable. Ultimately, biomass is a form of energy storage. Plants convert solar energy into chemical energy via photosynthesis. We can then convert that chemical energy into useful fuels. Why should it be used as a fuel source? Biomass is useful because it allows us to take advantage of the complex chemistry of living organisms. The chemistry of photosynthesis has evolved for at least 2 billion years. Natural selection has led to extremely complex and efficient processes in modern organisms. Artificial photosynthesis is an active area of research, but is not yet efficient enough to compete with natural photosynthesis economically. Plants have evolved to naturally proliferate in nearly every environment on Earth. This means that biomass can be cultivated in extremely vast areas. The wide variety of plant life on Earth gives us a broad selection of plants to choose from to optimize the chemical composition of biomass. So how can biomass be converted to useful fuels? There are several methods by which biomass can be converted into useful fuels. The simplest method is the oldest method: simply burn the biomass. This has many disadvantages. Biomass is a complex mixture of chemicals. Because of this, burning it produces many byproducts. These byproducts, categorized broadly as soot, are not only harmful environmentally, but can foul equipment. Other methods involve chemical alterations of the biomass to more useful fuels. Biochemical conversion is the oldest method. This involves degradation of the biomass by other organisms, for fermentation or digestion. Thermal conversion involves heating the biomass to varying degrees to alter its chemical structure. Biomass processes. Biochemical processes again take advantage of the naturally occurring processes to produce useful chemicals. The simplest and oldest biochemical process is fermentation. Fermentation has different definitions depending on context. For the purposes here, fermentation is the anaerobic processing of carbohydrates by microorganisms. Fermentation has been utilized by humans for at least 9,000 years to produce ethanol. Ethanol was consumed directly as a beverage instead of being used as a fuel. Typically, yeast consumed carbohydrates, usually sugars, to produce ethanol and carbon dioxide. Ethanol has approximately 60% the energy density of gasoline. Industrially sugar-rich plants are harvested and processed to allow optimal access to sugars. In the United States, this is typically done with corn. There are two methods for processing corn. Dry milling involves grinding the entire kernel, then forming a paste, which is fermented with yeast. Wet milling involves separating the kernel into constituent parts, then fermenting only the part containing sugar. The other parts of the grain are used for other purposes, primarily as animal food. Once fermented, the beer is then filtered and distilled to separate water from ethanol. Distillation is an extremely common chemical process that separates chemicals based on the differences in their boiling points. Ethanol and water form an azeotrope, which limits the purity achievable by distillation. Ethanol cannot be distilled beyond 95% ethanol. To dry ethanol beyond its azeotropic composition, methods other than distillation must be used. There are two primary methods used to purify ethanol beyond 95%. Pressure swing distillation. Changing the pressure of the mixture moves the azeotrope. The mixture can then be distilled at the elevated pressure. Molecular-sieve. Molecular sieves are materials that absorb specifically sized molecules. Molecular sieves are usually pellets of clay-like material. The approximately 95% ethanol mixture is passed over a bed of 3 or molecule sieve. The sieve absorbs only water, leaving nearly pure ethanol behind. The sieve can be regenerated by heating to drive off the absorbed moisture. Once purified, ethanol can be blended with gasoline to be used in existing cars. Another biochemical process is called amycrobic digestion. Rather than using yeast, bacteria metabolic sugar to form methane. This reaction represents the net results of many different steps. Once methane is formed, any of the existing processes used for reforming methane gas can be used, most of which involve the production of syngas, as Fischer-Tropsch and mobile MTG. Various levels of process complexity can be used to allow for increased efficiency. Simple collecting of manure or municipal solid. Waste, garbage, in a sealed container, for example, will allow for reasonable collection of methane. Controlling for composition, density of material pH, etc., will allow for more rapid production of methane via anaerobic digestion. Thermal processes. Torrefaction is the lowest temperature thermal process. This process is usually done by heating wood to 200 to 300 degrees Celsius in the absence of oxygen. Volatiles like hydrogen, methane, and water are driven off. The products are usually ground to a fine powder and pressed into pellets or briquettes, increasing the energy density of the material. These can then be burned in furnaces. This is the most primitive technique for the thermally processing biomass, but has few advantages. The material is made homogeneous. The material is sterilized, stopping any biological processes or rot. The material is made hydrophobic, allowing it to be stored in humid conditions. And the energy density is increased. Thermal processes involve heating biomass to varying temperatures in an inert atmosphere. The difference in the techniques is the temperature to which the biomass is heated. For some processes, air and water are injected at various times. The goal is to convert the large polymers that compose most biomass, lignin, cellulose, and hemicellulose, into smaller components. Heating to higher temperatures breaks the polymers down into smaller molecules. The three main thermal processes are, in order of increasing temperature, torrefaction, pyrolysis, and gasification. Pyrolysis is the next highest temperature thermal process. This process is done by heating biomass to 300 to 700 degrees Celsius in the absence of oxygen. Large molecules that make up the biomass are broken down into smaller molecules. The products are driven off as gas. The gas is cooled, condensing liquids which are known as bio-oil. Bio-oil has an appreciable heating value but also contains many useful chemicals. Reducing moisture content of bio-oil increases the heating value further. Separating bio-oil into its constituents dramatically increases its value. Hydrocarbons, phenols, ketones, and other alcohols are valuable chemicals that can be extracted from bio-oil. Gasification is the highest temperature thermal process. This process is done by heating biomass temperatures over 700 degrees Celsius in the absence of oxygen. Large molecules that make up the biomass are broken down into smaller molecules. The large molecules, including those that would be collected as bio-oil from pyrolysis, are broken down to produce hydrogen, carbon monoxide, and carbon dioxide. This combination of gases is known as synthesis gas. Synthesis gas is primarily feedstock for many processes, hence the name synthesis gas. Potential fuels from syngas include diesel-like fuels and gasoline. So what did we learn today? Biomass is likely to be an important part of the energy portfolio of the future. Natural processes, including photosynthesis, produce complex chemicals while removing carbon dioxide from the atmosphere. These complex chemicals can be biochemically processed to produce ethanol or methane. Biomass can also be thermally processed to produce one of several fuels: torrefied biomass for use in furnaces, bio-oil for further processing to many different chemicals, and syngas for further processing in many different fuels such as gasoline or diesel fuel. And finally, since the carbon that is produced during the combustion of biofuels came from the atmosphere as carbon dioxide originally, these renewable fuels are also carbon neutral. Well, that's all we have today. Thank you as always for watching, and have a good one.